My name is Jeff Yates, and I'm the head of product management for Havok. And I basically focus on product strategy for the company, and I specialize in one of our character products that we're building. As most people know, we started in physics, so we have a lot of technology for physics. But over time, we started looking at animation and blending physics and animation for characters, so they're more physical, but also still under the control of animators. But what we found was that there were really no tools that were aimed directly at working on real-time characters. So, of course, there are brilliant tools for creating animations and 3D shapes for characters, but the events that cause the characters to look at something or react or defend themselves, and the way those decisions are made usually is done with pure code. So we created an SDK, so the programmers can still do that if they want, but we created a tool for artists and designers who can bring all of the static animation assets in and put intelligence in their behavior. You could think of this as the last mile of behavior. Like, so I'm reaching for a door. If I sense the doorknob and I want to reach and I don't know how far it is, but I have the physics that tells me where the door handle is and how my hand needs to be, and so I can attach and open the door, and that's the kind of AI, you might say, we put into these character behaviors. There are game engines, and there is proprietary software in the very, very large companies, which sometimes is cared for and supported, and sometimes not. And but this kind of tool is I think first of its kind, because it combines a broad range right in the middle. So you can see all your animation, you can scrub it, you can see your physics, you can bring your terrain in and knock the characters around, but you can also start to craft the logic without having to write any code. And today we're announcing, actually, in fact, a public download of the tool. So anyone can download it and try it out themselves with their own characters, made in Max or Maya or Softimage, and just get to know and actually create prototypes and movies to show what's possible.
It's a time, I mean, it's to gain time.
Absolutely.
To do this kind of stuff. What kind of, do you have any idea of how faster it can go, for example?
Depends on how bad the pipeline is you're working with now. You know, if you're working with Excel spreadsheets and you're calling the programmers and artists, or sending emails back and forth to each other, maybe hundreds of times faster. Yeah, it really depends. I think that it's certainly, what does they say, order of magnitude 10 times faster. I mean, you get so much better turnaround, because you also know when you see it in the tool, it's pretty much what you're going to see in the game, because it's the same runtime technology, right? And I would say the other thing that's important about it, I would say, because I like using tools, but it's fun. It's very gratifying. It's very immediate. And in the same way that making Flash, as opposed to writing a Microsoft Word document, you know, it's just much more visual and much more entertaining. That's really what this tool is about. Let's say you're running a character around in a sort of third-person type of game, and you want to move the character forward. So the character needs to run and slow down, and they need to change that velocity intelligently based upon the kind of input you're giving it. So we can process that input, we can choose the right animations, we can blend animations, so the character will go where you want to go, but when you run into a wall, maybe it needs to bump back and react, and we can deal with that. We can also have the character just notice things. So you might be driving the character around, but if there's something on a table that's important to the gameplay, the character can notice, and the IK and the head will actually move, and even the character can reach out and try to go for that particular item. So you're still in control, but there's a lot of extra ambient motion that's going on. And the animator can control all that. It can be driven procedurally, or it can be driven with animation that they create.
Okay. So you can choose. You can say, okay, go on, behavior, take it on.
Exactly.
Or I want him not to bump on the wall, but to crash on it, so I just push it out.
And if it's a very animation-driven kind of style game, it can be pure animation. I mean, only animation assets. So I mean, many games are still very much that way, and you get a very classic-looking character that way. There's probably maybe a dozen or so plugins for each. So in the same way that you would rig a character for inverse kinematics or for film, you would rig it for the physics. You add volume objects for all the bones. You can add physical constraints, so they have limits, so that when the character falls down, the hand can't go too far behind the head. So you set all that up in Maya or Max or Softimage, and then you export, and it goes directly into the tools. And from the Havok behavior tool, it goes directly into the runtime game engine. These assets, and you can also just bring in the physical terrain. You can create a world with terrain and texture and objects and doors swinging, and bring all that into so the character has a world to exercise in, so they can see how it's going to work. Like with the great tools like Maya and Softimage and Max, these are very general architectures, and they have plug-in interfaces so you can put in a special functionality like inverse kinematics to move the feet over the ground, or IK to reach, or a blending node to combine a left turn and a right turn to get a variable turn, for example. So what we've done is create a lot of special nodes that snap into this runtime system. And we've opened the SDK so people can plug in their own as well. So by studying really the problems that people want to solve, we understand what the different nodes are that are needed, the twisting and blending and bending and falling and all these things. And then when you create a behavior, you create this tree of nodes in the same way you'd create a shader graph or a graph, a node graph in Maya, something like that. It's a tree processing. Also, it's for people who are not familiar with state machines, the really fun part is that you can jump from place to place. You don't just have one timeline, you have thousands of timelines, and you can transition and move around with events. So a loud noise goes off and you might go from running to stop or startled, and you get to craft all of that graphically.
Does it work?
Well, let's see. It's magic, and only we know how to do it. No, it's. I mean, it's software. It's runtime software, and you know, we employ a lot of the general ideas that have been, you know, researched and done in the industry today, and in-house tools here and there. But we put it all together in one complete system with a nice UI, and it's documented, it's got support, and we have videos that'll go up on YouTube to show people how to use it, and so it's good commercial software.
It's a service.
Yes, exactly. Yeah.